Magnetism in nature is an interesting phenomena. There are organisms that, of course, use the magnetic force of the Earth in their migratory behavior. An interesting example are actually monarch butterflies. And that's an interface between their antenna and the magnetic field of the Earth. What's unique about our work is that we have created a cell that will migrate towards a magnet.
Our study is the first demonstration that to make a naturally non-magnetic organism to magnetic.
What is partly the motivation behind our work is bacteria that are magnetic, and it's not clear why they're magnetic. It may be sort of an evolutionary artifact, but they can align themselves with the magnetic field of the Earth, and as humans we can actually find this to be very useful in terms of remediation and things like that. So first of all, the basis for the magnetism is the uptake of iron by the cells, so iron can become magnetic. And so the cells will naturally take up iron, but normally they will sequester it inside a compartment in the cell that's called an organelle. And when it's sequestered, the cells are not very magnetic. So one thing we did was to eliminate and inhibit the normal ability of cells to hide the iron and to make it more exposed. The second is to increase the uptake and the crystallization of iron to make it magnetic. And the third is to manipulate, to fool the cells into creating an environment where the iron will be more magnetic. Well, my favorite experiment that we did, and when I say we, I really mean KG, is that he could take the cells and put them in a dish and then hold a magnet underneath the dish, and the cells would migrate towards the magnet, and he could have them make patterns in the dish depending on where the magnet was. And so one of the things he did was have them make a pattern of a face. There's the potential medical applications. There's the potential for applications in bioprocessing. There's potential applications for tissue engineering. It could have particular importance in bioprocessing. So you have large vats of cells, and sometimes you need to pull out either the bad cells or the good cells. And so you could imagine if you had a giant magnet, you could suck out the good cells from a bioprocessor.
It could be also possible that you may be able to stimulate cells using external magnets and engineer cells to respond.
One of the interests is how do you make living forms interface with machines? So you want to be able to have cells that can communicate with machines. And so this is a perfect example of that. You can have a magnet and the cell can be communicating with it. So the magnet could be a form of input, the magnetism, and then the cell does something. And so this interface of life with machines is part of our future.